I will now talk about the delta function, and this is the delta function. It is not really a function, but in any case, we call it the delta function. This is defined in the following way. The delta function, it has the value of 0 everywhere else but 0. So when x is not 0, the delta function has the value of 0. When x equals 0, the delta function takes an infinite value. However, there is a constraint. The constraint is that the integral from minus infinity to plus infinity of the delta function dx needs to be 1. Okay, so it is a little bit weird, the fact that the delta function takes an infinite value when x equals 0, but this integral needs to be a finite number, and we define it to be, by convention, it is 1. Now I want to show you a little bit what is that. So let's say this is x, this is 0, plus infinity minus infinity. I'm gonna try to draw my delta function. So what it is, when you start from infinity, of course, everywhere else other than 0, my delta function is 0. And I'm gonna do the same thing. This is my delta function. It is 0, 0 everywhere else. But when you reach x equals 0, the delta function needs to take an infinite value. What does that mean? So really, this is my, okay, and it goes to infinity. This is my delta function. Anywhere else 0, at x equals 0, it goes to infinity. But as I mentioned, there is a constraint. Now, just for illustration purposes, I will do the following. This is my delta function. I'm gonna show you. Okay, now this is not really the delta function, but I want to show you the area. Okay, this integral, the graphical interpretation of this is that it's the area under the delta function. So if this is my delta function, this area needs to be 1. But you have to think, you have to remember that really it doesn't look like this. The delta function takes the value of infinity only when x equals 0. Now here's one more thing about the delta function. If I have f of x times the delta function dx, what should I do? Well, the delta function is 0 whenever x is not 0. So really the only, since this is an integral of this area, since this is 0 anytime x is not 0, then whatever values this function takes over here makes no difference, because the delta function is not 0 only when x equals 0. If this is 5, if this is 10 over here, it doesn't matter because you're multiplying with a 0. If your function f is 1 or 2 or 3 or 5, 10 to the 6 over here, it doesn't matter because you're multiplying it with a 0. So really, from this integral, the only important value of the function of f of x is the one when x equals 0, because that's the only one that will survive from the product with the delta function. Now, because it's a constant, you can take it out of the integral, and then you end up having this. But as I said before, by the definition of the delta function, this is 1, so this gives you the value of the function of f at 0. So this the delta function has the property of picking out, if you want, from this integral, the delta function can pick out the value of the function f at 0. Now, it doesn't have to be 0. I can show you how you can change that. If we have the delta of x minus a, then, okay, remember, the delta function takes the value of infinity when this argument is 0, or in this case when x becomes a. So what this will give me, this is the f at a times the delta function x minus a dA. I take out the constant, and of course this integral of the delta function, as we know, this needs to give us 1. So this is the value of the function f at a. So this is the process that you can use if you want to pick out the value of the function at any point along the axis. And there is a way that we can generalize this from one dimension to three dimensions. Say you have a function f that depends on the position. Then the way that we use the notation here is r minus a. And now, okay, before I did the integral in one dimension, now I have to do, this is going to be a volume integral, and this will give me the value of the function at a. Just remember, this is a volume integral. So this is this was a short introduction to the delta function.